At DVC Chandrapura Thermal Power Station, efficient coal yard management is critical to sustaining peak generation output, especially under variable load conditions. Vcpl, as the executing agency, will implement a comprehensive 12-month coal yard operation plan designed to ensure both quality and quantity assurance, while maintaining an optimum GCV ratio for reliable boiler performance. Yard zoning based on GCV quality. To begin with, we scientifically divide the yard into 4 distinct zones, each categorized by a specific GCV range. This zoning will allow systematic stacking, blending, and reclaiming of coal based on quality. Each zone will be clearly marked and color-coded to reflect real-time GCV values. Coal samples from each incoming truck or rake will be analyzed, and GCV values will be plotted on the record sheet, updated daily. This zoning system will help us maintain visibility of high and low GCV coal across the yard. Stacking and compaction. Upon arrival, coal will be unloaded using hydraulic excavators and loaders. Coal will then be moved to designated zones using wheel loaders and dumpers. In each zone, the coal will be stacked layer by layer. After each stack is completed, dozers will be deployed to compact the coal. A dynamic penetrometer checks weekly compaction levels. This compaction minimizes voids, reduces spontaneous heating, and increases bulk density, preserving the coal's calorific value over time. FIFO and GCV mapped blending. A key part of our strategy is FIFO, first in, first out. Older coal will be consumed first to prevent degradation. Each day, based on DVC's generation requirement and GCV mix, our site in charge will generate desired blending ratios using real-time yard data. To execute this, we will use a combination of wheel loaders, excavators, and dozers to simultaneously reclaim coal from 2 or more zones. This blended coal will then be loaded onto dumpers and transported to the bunker feeding area, ensuring the final mix meets the GCV target, especially critical during peak hour load conditions. Monsoon and fire safety protocols. During monsoon months, we will cover the stacks with high-gauge polyethylene sheets and maintain slow gradients with bunds to allow rainwater runoff. Drainage trenches will be maintained to prevent water stagnation. All equipment will be operated on raised compacted paths to prevent skidding. To prevent spontaneous combustion, our field supervisors will conduct routine temperature checks using infrared thermometers. High-risk areas will be treated with water sprinklers and compaction. In the event of a hotspot, we will isolate the zone, spray water, and rearrange the coal stack as per standard safety protocols. Real-time monitoring and reporting. We believe the effective use of manpower will ensure the project success. The site in charge will be responsible for stack planning, GCV monitoring, safety compliance, logs and reports, coordination with the DVC team, and giving status presentation time to time during the entire project cycle. The shift supervisors will oversee operations round the clock for 3 shifts. The skilled operators will be engaged for the dozers, excavators, loaders, dumpers, and water tankers. The unskilled operators will be used for the support work throughout the process. We will also ensure 95% machine uptime through regular maintenance, standby equipment, and skilled on-site operators. The entire yard operation will be supported by seamless project communication. and a site office that monitors stack movement, blending status, and yard health. Peak load readiness and coordination with DVC. During peak demand surges, we will prioritize reclaiming from high GCV stacks. Close coordination will be maintained with the boiler control room to allow blending output with combustion needs. This will ensure smooth, uninterrupted power generation without tripping or drop in turbine pressure. Through this integrated process, from scientific zoning to stack compaction, from GCV mapping to peak hour blending, Vcpl will deliver consistent, high-quality coal feed to the plant. Our goal is simple: maximize usable coal, minimize GCV loss, and ensure that every ton of coal contributes to stable, clean, and efficient energy output.